very much for the introduction. It's interesting hearing these other presentations. 285, I've this is what we deal with, but also understanding what's going on in the UK and how that affects other locations in the world. And you'll probably see some similar kind of thoughts coming through in here. But what I wanted to talk about, obviously I'm talking about the IBC, so it's in that context.
Sorry about that. I think Beth has just dropped out. If we take 2 minutes and we'll see if Beth can log back in. I know she's coming to us from not her usual location. I see she's rejoining the group now. There you go. Beth, you there?
Can you hear me?
Hi, Beth. How are you? You dropped out there.
Oh, that's strange. I'm sorry about that.
No problem at all.
Okay. I think I'm still in screen share. Can you see my screen?
You're not. I think you'll have to go again.
Okay. Hold on just a sec. Hold on. Okay.
There you go. That's you.
All right. Excellent. Sorry about that.
No problem.
I'm not sure where you stopped hearing me, but basically what I want to do is kind of talk about the bigger system of beyond sort of the exterior wall test and sort of the overall building kind of requirements for taller buildings in the IBC. So over 23 meters, pretty much we call them high rises, but tall buildings is when we sort of have this special use requirement regardless of occupancy. It doesn't matter if it's mercantile or if it's business or if it's residential. At that point, there's a whole set of provisions that apply just because it is a tall building. And which I think, this is where the risk of these exterior claddings is the greatest, although we do have other requirements at lower heights too, but wanted to point some of this out because we had a lot of questions after Grenfell, and they were just so focused on the cladding, and I think it's important to look at the whole picture of it all because we've also seen fires that look horrible, but thankfully everybody's been able to evacuate, I think, because of a lot of these systems that are on there. So, I mean, just as a sampling of what would be in a high-rise or tall building, as we classify it in the IBC, you would have sprinklers, emergency voice alarm communication, which allows zoned, evacuation, things like that. Standby emergency power for various systems, including elevators and other systems at, I want to say 120 feet, which I forget what that goes to meters, but that's when we start also requiring fire service access elevators, two-way communication at the elevator lobby for those who need assistance from the fire department to be evacuated, pressurized stairways. I do put that, it's a system, but it's also part of the egress. Passive, tall buildings are going to be fire resistant, non-combustible construction at their core, although we do have exceptions that allow the cladding that is not, it is combustible. Compartmentations, depending on the occupancy, will be compartmented differently, but there's floor separations. This is pretty common, probably any tall building, just by types of material, you start having to do more of this. And then we need for egress is at least 2 exit stairways, possibly more. And then having the pressurized stairways operating during an event as well. So, there's a lot of things going on, and I think that is key. Exterior cladding performance is obviously one of them. And I wouldn't want that to give way and let everything else make up for that. But I think it's important to understand that it's the bigger picture of the whole building as a system. Just as a, type 1, type 2 construction, we classify our construction type 1 through 5. It's the lowest combustibility, highest fire resistance, with some exceptions for exterior cladding that is combustible, but that is based on using NFPA 285 for the test. So actually, we haven't actually banned any materials, for instance, since everything has happened, but we have putting a lot of the, it's the system and it's the testing process with 285. We also do have, and I haven't really got into this, we have new provisions going into our 2021 code for tall wood buildings, which are actually a special type of type 4 construction, which is usually heavy timber. But as was mentioned with 285, we're starting to see buildings that are more combustible that are a bit taller too. What I want to do, this is only one slide, but hopefully kind of this is sort of the key of when do we use 285? I mean, we have this standard that gives us a really good sense of what happens in more realistic conditions. There is a lot of other small scale tests when you go through all of our provisions that you'll see. But in the end, it's the larger scale tests that give us the best representation of what it may behave on a real building. And when you go through and synthesize where this is called up in our building code, there's sort of two chapters. Chapter 14 is exterior walls, and chapter 26 deals with plastics, anything plastics. There's a lot of things going on in 26, but one of them is very specific to what we'd be concerned with exterior cladding. So basically, synthesized down, the biggest triggers are combustible water resistive barrier. Anytime you introduce one over 12 meters in the higher type construction, actually type 1 through 4, so almost all of them. Type 5 is all combustible construction. At about greater than 12 meters, you would need to test a 285 base. That's one trigger. We call ACMs, we call metal composite materials, anytime they're over 12 meters. We've had some cleanup we've done after Grenfell in the chapter for MCMs. We had some exceptions in there that we cleaned up to make it much clearer that it's greater than 12 meters, that you need to test a 285 along with a thermal barrier behind it. And then EFIS, that is actually not directly called up. 285 is not called up in there, but what we do is we reference ASTM E2568, which then calls up 285 for those types of systems. And then high pressure laminate, which I don't know how common that is used, but it has the same basic requirements for 285 as MCM. Or ACMs. And then I think that the trigger that kicks in the most is anytime, this is actually in chapter 26, foam plastic insulation. Anytime your building is over a story, with some limited exceptions for, everything's masonry except for the foam plastic. Anytime you're over a story, no matter what is on that wall in addition to it, whether it's MCM, whether it's, some other type of material, anytime you introduce that, you need to test a 285. These are all kind of independent triggers. I think at times there's been some concern that some MCM folks will advertise the materials, so they pass 285, but they pass it on their own, not within the system that it's being constructed. So obviously, most buildings, we're going to see foam plastic with especially, I know in the UK and the US, the energy restrictions are getting tighter and tighter. The only way to achieve a lot of this is through foam plastic. So that is a nutshell of when it sort of kicks in and when we need to deal with testing and making sure that we're integrating that with the building. But I think after Grenfell especially, and even reflecting upon some of these in the past, people kept asking, what can we change? And we went through the code, and what we realized is that it's really about the process. And obviously, Mustafa just talked about that in the UK. It's the same kind of thing. We kind of broke it down as permitting. That's kind of letting the jurisdiction know something's going on. But the plan review, kind of construction design process, conformity assessment, and then inspection. All of these are key to making all this work and as a system and being successful. And what I sort of wanted to point out is this, that this part of the process, the plan review, construction documents, that's how we term it. I'm sure it's other terms elsewhere, but essentially the design review, what's being submitted by the designers. And this is when you would be reviewing test results for wall systems, potentially. I know sometimes the testing takes a little while. That's part of the concern. But this is where the documentation is required, accredited labs, whoever, all that information as to what is going to be constructed is reviewed at that phase. And then this part is key too. And I think actually Mustafa was kind of talking about this. We call it conformity assessment. This is when you need accredited facilities, which when we're talking about MCM and high pressure laminates specifically within the IBC, it actually references you to a section that requires the conformity assessment that walks through how you're supposed to label and making sure you have approved agencies and accredited facilities that are actually manufacturing this. So you're having a label on this. This is kind of part of the whole picture of knowing that when it does arrive at the for installation, that you can more easily understand, do you have the right products that were spec'd in the plan review and construction documents to the contractors that you're actually putting on the building. I think this type of step strengthens the whole process, having all these bits and checkpoints along the way. And then finally, and this is a question I had probably asked a lot of people during presentations, is we can do all these wonderful testing. We can do conformity assessment, which I think, again, helps all of this. Not having it makes it more difficult to determine what you're putting onto the building. But I feel like in the end, how do we know what's getting on the building and how it's being installed on the building is how it's been tested and how it's been approved. And I think that is key to a lot of this. So the process is just as important as the code book, as the testing standards, and we need to understand all that together. And this is something I've talked to our major jurisdictions about, and we've, trying to come more and more to the conclusion, and also even working with IFSS a little bit as that's being developed, is we're talking about that we need the verification process. We need the right qualifications of the people in the process to start with: designers, manufacturers, plan reviewers, inspectors. These may be a little bit US-centric terms, I guess, but special inspectors, which is kind of like the next level up of inspection beyond typical building inspection, where somebody maybe continuously, we use it a lot with structural design, continuously monitoring concrete, and other structural elements that are going into buildings. And the verification process. This is the key. You have to have jurisdictions that are involved in the process that have, the safety of the public as part of their requirements, the accreditation bodies. I think all this supports the verification process and the product evaluation process, like evaluation reports for different products. So you can verify, all right, they spec this is what I'm seeing. Here's the report to know that that product is the right one. So, sharing sort of ICC's perspective, because ICC publishes a code and that's what we're known for, but there's a lot of other things that we do that we hope as part of the system, and it supports our membership, a lot of building and fire inspectors and plan reviewers, and also designers and industry. But there's key, certifications out there for plans examination, commercial building inspector, and a lot of this stuff is offered 24/7. So we try to provide these services. And a lot of this, we'll see, there's a reference, you can see more on the global site for ICC. But we also have education. And I think also what's key is the building and fire department and special fabricator accreditation through IAS. It's just something unique. Many building and fire departments in the US have been using this concept of accrediting themselves or getting accredited as a quality type approach. Obviously, ICC Evaluation Service, they have evaluation reports on a number of products, and it helps kind of bridge the gap between innovative products and the code not necessarily quite being there yet, but it provides that bridge. And then we have NTA, which is now one of our newer part of our code council family, is They have our accredited test lab, and they also do third-party inspection of modular components and pods at factory level. So I just, we feel strongly that it's the full circle, not just the code itself, but the whole picture of the whole process. And I feel pretty strongly about that as well. So in conclusion, we have to look at exterior cladding because that's key, but it's also part of the bigger picture of the fire safety that goes into a building. Testing is obviously key to real world performance. Small scale testing is not enough. We do need something that represents more large scale, more realistic fire hazards. And the approvals process needs to be robust to make this work. And we need to know who, in the end, is the right material that's been tested, that's been approved, certified. All of that, is it being constructed appropriately? And I'll leave you with, and I assume you'll have some access to these slides, maybe some links to our global folks and a couple of our documents that we've worked up and some podcasts that we've done related to this topic of exterior cladding. Thank you.